Hey everybody, this is Mr. Longo, and in this video we are going to cover some basics of polynomial functions. Many of this is going to be review, so let's just get to it and it'll be pretty quick. The degree of a polynomial function is always the highest exponent of any of the terms. So this example would be a fourth degree, which is known as a quartic. You'll have like a cubic if it's a third degree, but the highest exponent is your degree. The leading term is the term with the highest exponent. So your leading term would be 3x to the fourth power. So if you were writing your polynomial functions in standard form, it's always descending order, so that's why it's usually the first term, but if it's not written in standard form, you have to find the one with the highest exponent. And a constant would be a -6. It is the term without a variable. You would just consider it a number, but it is a constant term, meaning as you substitute values in for x, that constant will never change. So now let's just talk about a few graphically, just so you have an idea of what some of these graphs are going to look like. So we all know that y equals x is just a line. But there's a few things that you need to be able to notice, is that it starts low and finishes high, which basically means in terms of its end behavior, as x approaches negative infinity, f of x approaches negative infinity, and as x approaches positive infinity, your graph approaches positive infinity, as we've talked about with end behavior before. But what happens is if you decided to make it negative, then it switches. Basically, it just starts high and finishes low. That's what the end behavior will do. Same thing's going to happen when you work with this next example. When you graph it, a negative one will just be upside down. So one of the things you need to look at with the end behavior of an even degree, since this is x squared, they're both going to finish in the same direction. So your end behavior is going to go up in both directions, to negative infinity and positive infinity. When you reflect it over the x-axis or make the function negative, they are both going to go down. So that is one of the things that's going to happen with your end behavior. So if you have an even exponent and you have a positive, then as x approaches negative infinity, your graph is still going to approach positive infinity. And as x approaches positive infinity, your graph is still going to approach positive infinity. So if it's an even, your end behavior is going to be the same. Now, if this was negative, your f of x is going to approach negative infinity for both of them. Now, when it comes to odd, let's look at this one again. If we were to reflect this over the x-axis, it would look a little something like this instead. So it'll start high and finish low if it's negative. Positive is going to start low and finish high. So again, with a positive, you are going to have, as x approaches negative infinity, your graph will approach negative infinity. As x approaches positive infinity, your graph will approach positive infinity. So they will follow each other. But if you make it negative, then these are going to switch. Okay? And same with this guy. If you were to, this is what a quartic would look like. It's going to look something like a W. So a few things you need to know about different functions is if it's x to the fourth, you could potentially cross the x-axis 4 times. It's going to have 3 turns. There's a whole bunch of different things we're going to talk about once we get there. But this is just an idea of what we're going to be dealing with when it comes to polynomial functions. Again, the end behavior, if it's even, will go in the same direction. So if it's positive, they both go positive. If it's negative, then they're both going to go negative. So I will just put the negative over here. F of x would approach negative infinity, and f of x would approach negative infinity. If it's odd and it's negative, as you approach negative infinity, it's going to go to positive infinity, and as x approaches positive infinity, it's going to go to negative infinity. Okay, so that's just a little preview. We're going to do much more with this coming up. So for this one, we'll just call it quits. This is Longo, and I'm out. See you, bye.